All right, so welcome to session 4. This is ICT for secure and smart communities. And the first presentation we have today is Trustable Global Navigation Satellite System for secure community and applications. And the presenter is Professor KIAT. Please.
Yeah, good afternoon, everyone. Good afternoon, committee and participant. My name is Dr. Seow from University of Glasgow. Today, I'm going to present a topic on Trustable Global Navigation Satellite System for secure community and application. So what is GNSS? Basically, GNSS is the baseline technology to provide prediction, timing, and velocity in various aspects of application. One of the very common GNSS that in our daily life is the GPS from US, Beidou from China, QZS from Japan, and of course Galileo from European. So what does this GNSS do in this nowadays world, especially in terms of smart initiative? So example, in terms of so-called the smart grid, we will have so-called GNSS timing is important to make sure the synchronizations of the so-called power signals is always maintained. Secondly, in terms of smart finance, so the GNSS timing itself is need to be so-called being used to record down the precise timing of the transaction. And of course, in terms of smart network, the comms network, be it 5G, 6G, nowadays, especially 5G, we need to provide millisecond latency. And of course, this in order to fulfill this capability, the reference signals must be even high resolution in terms of milliseconds or in terms of microsecond, and that is provided by the GNSS timing. And lastly, for the so-called smart transportation, especially autonomous vehicles that is going to roll out pretty soon, or rather slowly in every country, they are trying to move, implement. All these rely on precise GNSS timing and partitioning. So example, during COVID, we have been so-called stay at home, doing all these Grab delivery. All these so-called services is being unable because of this GNSS timing and partitioning. And what happened if all these so-called GNSS timing in terms of timing, partitioning, and velocity has been so-called spoofed? So it has been proved by Tesla that a simple $200 spoofer can manipulate the sets of a fake GNSS satellite to change all the information of the partition, velocity, and timing. And of course, has that been done in so-called spoof in our ASEAN country? The answer is yes. So for example, in ASEAN country, we suffer some of the GNSS spoofing threat. In Malaysia, it has been known that Grab drivers steal bookings from other drivers by doing spoofing. And Grab driver also give their fake locations to the Grab company, such that they do not want to take a job that is not in the preference. At the same time, recently, I think it's 2 months ago, in September 26, 2022, it has been suspected oil tank has been spoofed and caused collisions in the so-called with another so-called tanker along the Strait of Malacca. And of course, the other thing is it has been known that so-called spoofer can masquerade as a potential Grab driver to customer, and somehow it may cause some dangers to the customer. In Indonesia and Singapore, it has been shown that driver itself spoof their location for these GoJet so-called apps, such that customer at the preferred location can be assigned to them. And the target of this so-called proposal for today's is to so-called provide real GNSS signals to any company and application that make use of GNSS, such as transportation company, not limited to, example, Grab. And of course, any GNSS user, especially ladies and kids, because it may so-called endanger their so-called the life. And lastly, but not least, is the national infrastructure, such as 5G and 6G, because all the important timing reference arises from all the GNSS timing. So I think here is a few picture whereby $200 head RF that can be buy from so-called online. At the same time, all the source code has been easily available. It can be shown that this driver example, install all this software inside this area, and it can so-called spoof their own location or even the nearby vehicles. So we have so-called since 2 years ago, we have so-called do a development work with Singapore Land Authority. It has been funded by GovTech, which is under the Singapore Prime Minister Office at the so-called funding about 800K to develop GNSS navigation message authentication over the continuous operating reference system network. So this phase 1 prototype development basically is for Singapore Land Authority. They have around 8 reference stations in Singapore, and is jointly developed by University of Glasgow, Singapore, NTU, and University of Tokyo. So what does this so-called this GNSS authentication system work? Basically, the real GPS signal has been so-called received by all the reference stations. For example, by the one at NTU, we use NTU as a reference, for example. And of course, the real signal has been so-called rubber stamp with a digital signature. And this digital signature will eventually send out over the cloud network to over the cellular network to all the IoT devices on the ground. It can be any so-called Grab taxi, autonomous vehicle, or even the cellular handphone. And in the event that there is some spoofer out there, so for example here, there's one spoofer out there, it is sending a spoof GNSS signal to masquerade that it is a real GNSS signal. However, for example, this autonomous vehicle, it is receiving so-called the real signal, GPS signal, and the spoof signal. But at the same time, it has been receiving the digital signal for the real GPS signals. It will able to so-called correlate. So, example, the spoof signal has not been rubber stamped with digital signature for the so-called by the reference signal. Therefore, it will be so-called validated by the IoT devices. In this case, autonomous vehicles say that it is not a valid GNSS signal, and therefore it should be thrown away. And this is some of the experiment campaign setup that we have done together with NTU and University of Tokyo, whereby this core network itself, basically, in short, basically the GNSS signal that received by this core network, the messages will be so-called being hashed and create digital signature. This hash key and the digital signature will be put inside the database. So in the event that the client, regardless is any IoT devices, want to validate whether this particular GNSS signal is valid, is real, therefore, this so-called the receiver itself will go to the so-called database to fetch the so-called the digital signature for the real signal. And in the event that even there's a spoofer, it will say that because spoofer don't have digital signature, it will be valid that it is either invalid or a spoof signal. So therefore, it will be successfully thrown away, or rather to identify the spoof signal. We have done some experiment using so-called this RF. Okay, basically it's a simple device, $200, we will create a spoofer, and then we conduct, of course here the picture only show 2, there there's more than that. So basically we have done some experiment in the so-called outdoor environment, and you can see that under here, this is so-called supposed to have 6, but then in the event that there may be some spoofer, you identify that there is only 4 valid. And this is the experiment at the open area that we've done in the NECTEC so-called open space, where one of the handphone is mainly as a server and the other handphone is mainly as a client. And of course, all this authentication has been done over the cloud. This is using something called channel hashing algorithm as part of the so-called delivery. And inside the so-called, under this so-called project, which is an 18-month project, we have so-called fulfilled the requirement that given by the authority. The KPI so-called given for us is successful rate is about 90%, 95%. But however, for IoT devices, we have reached 99.4% success rate. And for the Android phone is 99%. So as you see here, we conduct some experiment in the so-called on the rooftop of the NTU so-called S2 rooftop, AAA rooftop. And basically, the handphone itself can so-called the client itself can authenticate which satellite is considered the real one or fake one. So for example here, because authentication has not been successfully done for the so-called satellite SPD-8, therefore it says that it is totally so-called not successful. So with the success of so-called phase 1, we hope that we can outreach to so-called this technology to Malaysia. Why? Because there is in the East and West Malaysia, there is 79 call stations in the so-called West Malaysia and 21 call stations in the Sabah area. And of course, there is a so-called 6 more for particular purpose like Marine Department, 1 for so-called the Civil so-called Aviation Authority. And there is also 23 R&D core network for us to play around or to so-called implement. And therefore, we would like to suggest to outreach to Malaysia, we can leverage on these 23 so-called R&D core station. And what is the impact if we roll out this so-called GNSS authentication for Malaysia? Of course, phase 1 in Singapore. So in Singapore, the success of the so-called GNSS authentication scheme, we have so-called Accelerate Very Smart Nation initiative that basically rely heavily on GNSS, especially for SLA. They primarily need to give CM accuracy, GNSS accuracy, position accuracy to the customer, especially for the so-called construction. And therefore, this can help them to prevent so-called spoofing on the piling, and of course for drone building facade inspection. And of course for SI and GovTech, they can build secure mobile apps for community. In Malaysia, because if going to implement this, we definitely can so-called remove all the above mentioned GNSS threat for business accessibility. Driver will be assured of the guaranteed livelihood. Commuter will be assured of the safety. And finally, national infrastructure can be so-called integrity can be maintained. And especially this is also one of the key objectives of Malaysia Space Agency. And one of the most important things that part of this project is that Malaysia government smart initiative that so-called, especially the Kuching urban transportation system, they are going to implement fully autonomous transport systems. So for example here, the system itself will be fully autonomous. And in terms of collaboration impact, we are trying to definitely based on phase 1 that already include NTU, University of Tokyo, and Glasgow, Singapore, we can extend to UTM, UNIMAS, and Sumber University, and of course the core network partner in Johor and Sarawak. And this is similarly based on the so-called implementation, we would like to leverage on Johor, the Iskandar Net, and Sarawak, the so-called Sarawak core network, and this so-called this is similar to what we have done for phase 1, except that we need to adapt to local context. And the outcome here is, in terms of outcome, we are trying to develop new customer GNSS solutioning for local context, and of course, eventually, transfer know-how to local company, like example, the KUTS company or GNSS cybersecurity startup, and also pave the way for the future nationwide big data analytics. And in terms of outcome, as mentioned, we not limited to, currently we have cooperation with NTU, University of and University of Tokyo, and we currently we have talked to UTM, UNIMAS, and SUTS, and the core network partner in Johor and Sarawak. We definitely, it's not limited to all this, we can welcome more collaboration. And finally, the target, as mentioned, is to prevent malicious spoofing by providing real GNSS signal to any company application that make use of this GNSS signal, and of course to any user, especially ladies and kids, and finally the national infrastructure such as 5G and 6G. And the method is basically GNSS authentication on the navigation message. And finally, as usual, as mentioned just now, we want to make sure this novel centralized GNSS signature can provide business accessibility, safeguard the livelihood, and protect the safety, personal safety of the ladies and kids for private right, and finally the national infrastructure reliability and integrity. Thank you.
Okay, thank you. I think we have time for a very quick question, maybe within a minute or so. Anyone? Yep, there's a question there, the lady there.
We saw that you have like a high accuracy on the testing. So I'm wondering, is there anything that you need to compromise to arrive at such results for the testing? Any compromise that you make to receive such very accurate results?
Because this is when we sign the contract with so-called GovTech, there is a few criteria. We need to ensure 95% so-called authentication rate under certain environment. So one is open era, one then is so-called not so open era. So there's some accuracy involved. Okay. So of course this one is currently it's open era, and of course the project is going to be another 3 more months. Okay, to move to more testing. Of course we need to see all this multiple environment will affect or not. Yeah.
Okay. Thank you very much.
Okay. Thank
Thanks.
you. Thanks.
All right, so our next topic is investigating the detection of tortured faces in scientific literature. And our speaker is Ms. Puthineath.
Good afternoon, ladies and gentlemen. So my name is Puthineath, and I'm from Cambodia Academy of Digital Technology. And today I'm delighted to present my project is exploration of the tortured faces detection. Okay, let's get started. So first, I would like to introduce why we come up with the idea to detect the tortured faces. So first, I want to present the work of the Biplab. They claim in 2021 that the meaningless randomly generated scientific papers end up being observed and sometimes sold by the various publishers with a prevalence estimated to 4.29 papers every 1 million papers. So it means that even there's existing scientific papers, but some paper is still fake because of the fraudulent researcher. They try to create a fake paper to sell. And as the Biplab, they also try to figure out how they generate the fake scientific papers. So here are the tools. For example, the MassGen tool and the SciGen tool. This website, yes, this tool can generate the mathematical research papers. And one more thing, when they try to deep dive to the root cause of how they try to generate the weird phrase. So for example, the phrase artificial intelligence, it should remain the same in every context. But when they use in the paraphrasing tool, it becomes the man-made brain powers. And sometimes it's become the counterfeit consciousness. So when we read it, we think it's not the human generated, it's machine generated text. All right, so now I would like to introduce 2 new terminologies, is the total phrases and the expected phrases. So the total phrases are the unexpected weird phrase instead of the established one. For example, like the phrase that I mentioned earlier, like the counterfeit consciousness or the man-made brain power, we consider it as the total phrases. And its expected phrases should be artificial intelligence. And I would like to introduce some more total phrases, for example, like the unused York. And we see it's in some phrase, in some paper. Actually, it's the New York, but because the paraphrasing tool try to paraphrase the word new, so it become unused York. And one more thing about the algorithm, like it's the innocent-based algorithm. Actually, it's the nail-based algorithm. And for another example is the imaginations. Actually, it's the expected phrase is developing countries. All right. So my objective of the study is to detect the new kind of the unlisted total phrases in the sentence automatically, because before we have the human evaluation on what are the total phrases. So we can only detect the total phrases by doing the rule-based with the pre-listed total phrases. So by make use of the machine learning and deep learning tool, we want to detect the total phrases automatically. I mean, refer to the unlisted total phrases. For example, if we try to detect what, I mean, to see the phrase, it is yes or no by doing the binary classification, for example. It is, well, for this example, we try to detect the total phrases. So it is commonly acknowledged that FDI is one of the essential wellspring of capital inflow and driving component of financial development in many great creating nations. So we just want to create a model to detect that the phrase is the total phrase or not. Yeah, and as we know that the expected phrase corresponds to the creating nation, it should be developing countries. All right. So up we have try to find how to create a model to detect the total phrases. And what we have in hand right now is the data set. So we have two kinds of the data set. So the first one is the list of the data set. I mean, the data set of the what are the total phrases that are annotated by the contributor of the annotator to annotate what are the total phrases correspond to the expected phrases. And in order to for our model to learn, I mean for the machine learning to learn, we need the context that contain the total phrases. So the next data set we got it from another paper from Biplab et al. In 2021. It's they have the paragraph that extracted from the Wikipedia or account thesis, and they extract those paragraphs, and then they use the spinboard and the spinner chef tool to generate those kind of data set. I mean, those kind of paragraph, and then when we try to detect whether those paragraphs contain the total phrase or not that we mentioned in the data set number 1. So we got a list of the context that contain the total phrases for our machine learning to learn. Okay, so these are our techniques that we use. So there are two kinds of the techniques. So the first is the machine learning classification, and the second one is the cosine similarity computation. So for the classification task, we try several classifiers. So the first one is the random forest classifier. The second one is the perceptron classifier, and the last one is the, I can say, the popular or the state of the art classifier. It's a transformer-based classifier. And for the second computation is the cosine similarity computation. We just want to know the similarity of the two words. And in this context, we try two different word representation, because we want to measure how the different or how similarity are the words. So we need to use the word vector representation, and there are several kinds of the word vector representation, or we can say the word embedding. And we in this experiment we try with two word embedding. So the first one is glow, which is the pre-trained embedding, and the second one is the bird, is the I can say dynamic word embedding. So for example, I want to mention about glow, or the difference between glow and bird. The example here, if we try to know the similarity of the word bank, like the bank in the context river bank and the bank in the context bank account. So these two banks has different meaning. And if you use glow, these two banks have the same meaning. So it's the similarity is 1. And if you use bird, so these two banks have different meaning for the bank in the river bank and the bank in the bank account. So the similarity is only 0.6. Okay, so these are the results from the experiment. We just try with the different classifiers and try with the different data set. We try to and the best result is to use the transformer-based classifier. And yeah, and we also use different kind of the data set, like the 5 gram. We try to split the sentence into five words, or sometimes we try to train our data with the whole paragraph. And we see that the data, I mean, the model that they trained the data with the 5 gram and do the transformer based yield the best result among of the classification tasks. And then move to the second experiment is to use the cosine similarity comparison using the globe of bird. So as you can see, the box, box plot on the left hand side, we use the bird embedding, and the right hand side we use the globe bird embedding. And as you know, if you use the bird word embedding, we don't see the difference between the expected phrase and the total phrases. So for example, I compute the cosine similarity of the 2 phrases. I mean, the phrase that has 2 words, for example, like the New York, or creating nation, or man-made brand power, or something like that. So I try to compute the cosine similarity between New and York. Yeah, this is how we do the cosine similarity there. So for the use bird, we don't see any much difference between the expected phrase and the total phrase. But if you take a look at the globe word embedding, you can see the difference between the mean of the expected phrase and the total phrase. We can see that it's around 0.3 for the mean of the expected phrase, and 0.1 is the mean of the total phrases. So we can see the result from the globe embedding from the experiment. Yes, because it is just the investigation how to differentiate or identify what are the total phrases. So the outcome, if we can create a model that can detect the total phrases, is have the user or researchers or some readers to avoid the fraudulent papers. And for now, we only do it in English. So in the future, if we can do this, complete this model, we can adapt it to other languages like Khmer, Thai, or Lao, and something else. Okay. So yeah, the outcome is it's just a model that can detect the machine generated text, and even the source code and the data is available online. So if anyone want to adapt or improve, or you want to learn or investigate more about this kind of research, you can take a look at the data and the code online. So the conclusion is, as I mentioned earlier, is the transformer-based classifier. It's outperform other classifiers, and the cost. Sorry, and the cosine score using the pre-trained embedding perform better result. And because our data set is small and we need much data set for our training, so we need more data set, a bigger data set for the training. And one more thing, if we could try on other experiment, like on other classifiers such as SVM or naive-based or something like that, we can see the difference. And for the cosine similarity computation, if we can try with other words embedding such as Waree and FastTech, so maybe we can get the different or better result. And thank you. And these are the references. And if you want to see the detail, or you want to see the code or the data set, you can see go to the last paper. Yeah, like the investigating the detection of the total phrases inside scientific literature. And that's it. And here are, thank you for your attention. And this is my contact. Yes.
Thank you.
Thank you.
Right, we have time for questions. Anybody wants to ask? There's a question in the back, please.
Thank you for the presentation.
Thank you.
Two questions from me. So the first one is, is this definition of tortured phrases, they're only applicable to noun phrases? Because it seems like from all the examples that you gave, they're all noun phrases, right?
Oh, Yeah, I can say it is the total phrases that we have, and yeah, actually it's mostly noun phrase. Yeah, because when the annotator they try to annotate, they try to find it from the paragraph or the scientific papers, and yeah, I mostly noun phrase.
Do we see anything, like tortured clauses, or something that's not uncommon? It's something that's a little bit uncommon, but it's not just a noun phrase. Do we see that as well?
I'm sorry, can you repeat the question, please?
So so can we go beyond noun phrases, uncommon way of writing certain clauses? Do we see that in machine generated papers?
Yeah, I think it can go beyond a noun phrase, because for now, because of the listed total phrases, yeah, I can figure out that they are mostly noun phrase.
Got it.
Yeah.
So I guess second question is more general. These days you probably know about GPT-3 and all these large language generative models, right? Which can generate articles without actually using all these tortured phrases, right? It looks very natural. Any thought on this?
Yeah, because of some research, they also mentioned that it's really human-like text.
Exactly.
For example, like GPT-3 or something like that.
Yeah.
But in some small errors, it still contains, I can say, the total phrases. That's why, to avoid those kind of errors, but that's why we want to create a model to detect the total phrases.
Got it.
Yes, thank you.
Thank you.
Thank you.
All right, I think that's sort of all the time we have. So we'll move on to the third topic for today, which is spoofing detection in automatic speaker verification. All right, and our speaker is Kasorn Galajit.
This one, okay. Good afternoon, everyone. My name is Galajit. I'm from NECTEC, Thailand, and today I will present my work. Instead of my team, I will present the work that is cooperate between NECTEC, SIT, and CHEE from Japan. So the title of the work is a spoof detection for automatic speaker verification. Okay, let's go on. Why we focus on automatic speaker verification? So in here, the application that about the speaker verification is rising in using to verify person and to verify speaker. They may use the physiological features such as iris, fingerprint, ear, or DNA. Or sometimes they may use the features such as behavior, like your signature, how you walk, or your voice. So in our work, we focus on voice. And why is this voice? Because our voice is now is more using in many sections, like for technology domain or financial domain. So it's quite important and sensitive to verify. So in here, let's say we have the speaker verification. So when someone wants to verify, here, John wants to claim this is John. So speaker verification will just whether this is John or not John. So if he is John, he can continue doing something in name of John. So what is the problem in this system? So the problem is the spoofing attack. That means it may have someone try to make John voice, or some tool that synthesis John voice, or some conversion program that try to make John voice, or even the replay of John voice. So in this case, we need some tool or some countermeasure to detect that kind is the fake one, not the real John voice. And so in this speaking, I want to invite you to participate in our project. In here, we want to make the spoof detection. So here we already have an ongoing project that we already running. So on our ongoing project, we check contribute of a void part and non-void part for spoof detection. And also we check the pathological feature for defect detection. So on the work that we will going to find partner by using the platform from NICT, that is the ASEAN IVO network here. I want to recruit the partner to join our work. So do something more about the spoof detection. So in here, we will investigate the significant feature for spoof detection. And for each feature, we also try to check the contribution of void and non-void for each feature. Also, the pathological feature that we already use for defect detection, we also consider to use it for spoof detection. So if we can use all of this, so the error detection of our spoof system will decrease, and also we also consider to use to make the multilingual spoof detection. And okay, let me introduce some of our work. So in here on the table on the above, you can see that not only voice that contains spoof feature. So you see that if we use only voice, the error detection of a system is still high, but the spoof, the feature to detect spoof is contained in non-void. But if you use the word utterance, the error will decrease. So in our work, we check the contribute part of void and non-void. So you can see that when you use the different percentage of void and non-void, the error of the system will decrease significantly. So here is our work that we already checked. And we also check for audio defect, that the defect is using some kind of speed synthesis tool. So this tool can make the voice with high quality. So when we want to distinguish with the human voice or defect voice, so in here we use this feature to identify. So in here we also try to use this feature to check the speed spoof detection. And okay, let's say our idea for proposed method is instead of go directly to automatic speaker verification, we will add the spoof detection here. Whereas if the fake voice will eliminate from the system, just only the authentic voice that's go to automatic speaker verification. That means the security or the system will be more secure. And in order to do the spoof detection, in this work, we will check the significant feature that important for spoof detection. And we also check the percentage of void and non-void for each feature. And also we will investigate the pathological feature. And finally, we will minimize the error detection. And when we minimize error detection of the spoof detection here, the accuracy of the ASV system will also better. So, and we also plan to study multilingual for spoof detection. So in here, when we expand our work from spoof detection here in the big picture, we can see that we will investigate so many features here, and we also investigate void and non-void of each feature. And we may use the different classifier. And lastly, to improve the error, we use the fusion here by using the Dempster-Sheffer theory here. So in here, we may add the fusion here with the different percentage of the void and non-void or different feature, and also different classification. And how can we know that our system work well? They have the baseline that have the challenge that about the automatic speaker verification and spoofing countermeasure challenge. That this challenge start from 2015 and is had every 2 years. So if we want to know our method it work or not, we can compare with the baseline from that challenge. And in order to make the new data set that we intend to make the Asian member state language. So in here, we intend to use the common voice data set and make it to the data set to check for spoofing detection for the language inside the Asian member state. And so when we talk about impact, so it had also the direct impact and indirect impact. So we can say that when we improve the accuracy of the ASV, when we can use our knowledge all that about the feature or pathological feature, then when we directly improve the accuracy of ASV. And for about the data fusion beside the ASV, it can use for another application as well, that is indirect. And when we can make the data set for spoof detection about the language in the Asian member state, so it can public for another group or another person who interested in this work to improve the accuracy or try to investigate more in this field. And for social impact, if you can improve this system, so this system mostly used in the banking application or online shopping platform. When you improve its accuracy, that means the security of the system will be more better. So in here, so from our work, the outcome and the output that we expect from our work. So from the thing that we explore the knowledge, so we intend to make it as a scientific, as a publication or prototype or patent. And also, as I said, we can make the database for sharing to detect spoof detection. And for social, we also intend to make some kind of application. When you input some voice, the application can tell you whether that voice is the real voice or is the fake voice. So the fake voice is may synthesis voice or replay voice, or someone try to mimic the voice of another person. And we also expect the collaborative between Asian countries, that we can make the data set for multilingual spoof detection. And let's go on for my conclusion. So the problem that we want to solve in this one is a spoofing attack in automatic speaker verification. And our target, our aim is we will make the spoof detection system. So in order to make the spoof detection system, so the work that we must do, that we must investigate the significant feature that have that's important for a spoof detection. And also we must find the optimal percentage of voice and non-voice for each feature. And we also investigate the pathological feature. And we try to minimize error detection by using data fusion. And we also try to make the multilingual spoof detection. That is for our target. And the method that we use, that when we find the significant feature, we use the significant feature, we find the optimal voice and non-voice for each feature, and we use pathological and we use data fusion. So finally, we will get the system that low error rate that make the effective automatic speaker verification. And for a scientific and social impact, we want some kind of publication, patent or prototype, and we will have the data sharing among the Asian member states to check for spoof detection. And that is all. So if you're interested in, I'm sorry that I forget to put my email in this presentation. So I'm still be around here if you intend to join us. So you can come and talk me. Thank you.
Right, we do have some time for questions. Anybody wants to have a go? Yep, there's Mr. Seow².
Thank you for your talk. Interesting topic. At the moment, do you have a good idea on what are the good features for spoofing detection?
we just investigate some feature and not really all feature because it have many. So in here, when we show that ongoing work, we investigate only MFCC, and we also intend to investigate the pathological feature. We also see some kind of characteristic that if they have how to say, if the fake voice and the real voice is characteristic is quite clear. So right now I cannot say which one is the best one, so we have to explore more.
Okay.
But the feature that are correlated to how your vocal voice is produced, the sound is more important, I think.
Thank you. I have another one. The application of this work meant to be the voice speak over the phone, right? Speak over some, not face to face, but
Yeah. Right now, yes.
In that case, the voice itself must go through all many other process along the way.
Yes.
Will that actually make things harder for you?
But they have some kind of characteristic, even though it's the record voice, but they have the characteristic that you can identify some different. So right now we are not like a physical access to just speak to the system directly, even though on the experiment right now we use the record voice.
One more question, maybe? Yep, there's a question there.
Thank you. Related to the first question, I think, do you have some sense of, this feature, are they sensitive to language or gender or age or accent even? Any
Right now, not yet.
Okay.
Right now, we investigate only some that the data set that they are not depend on and only English language, and they are not categorized about the age of the speaker or gender. Oh, gender is classified different gender. For female, for male is more difficult to detect. Yeah.
For male is more difficult.
Yes, because the tone is, but for female is some kind of swing.
All right.
Yeah, so we try to investigate separately male and female. You to try that.
Right.
But for age category, not yet.
Got it. Thank you.
Hi.
All right, so I think that's all the time we have for this session. So let's thank all the speakers once more.